All right, done.
This meeting is being recorded.
Okay, well, hello, everybody. It is March 16th, 2023. This is going to be a workshop on hands-on workshop on two technologies that are used extensively in R1 release of Nepio. So I will say I'm not an expert on them. I am learned them the same way I'm actually showing them right now. So we do have John here who might be able to answer some deeper questions. But the point is really not to teach them extensively with every single feature they have in every way, but really to give you an idea of how they basically work and what they do. So let's start. First, I'll ask, does everybody have access to a machine like I stated in the instructions, either Fedora or Ubuntu? Well, people are not going to say no, but I'll say this, even if you don't have access, I mean, you can still follow through and see me run the commands and everything. I think you'll get a little bit less out of this workshop, but maybe you can at a later point follow through with the video and try to do it yourself if you're interested. So let's start by cloning this repository. So I already have it cloned, but you can, I'll put it in the chat just to make sure. Chat. So this is a repository. This is my kind of scratch repository where I put all of my Kubernetes related experience in. So we're not going to use all of it. There's a whole bunch of other stuff, but we will use two things in environment. So I'll just tell you how this repo is basically structured. There's environments which are complete kind of testing environments, but they build on building blocks that I have under platforms, which is setting up Kind, Minikube, or Vagrant with Kubernetes. And then workloads, I have a long list of stuff that I can deploy on them. So we'll go over into detail here. You see config sync, you see git, you see Porch, right? Some of the components we'll be using, and there's some other stuff. But the point here is to be able to run this as much as you can without sudo in an existing machine. So if you have bare metal or if you have a virtual machine, it should work. I will just note one thing. Is anybody here using VirtualBox to run their virtual machine? Anybody? Okay, I'm not getting any yes. So because there is a specific aspect with VirtualBox, I'll just show you if people following along with the video just to make sure. So in VirtualBox, you can install your machines, but you do want to make sure that under settings, network, the default in VirtualBox is to use NAT. And it will create some problems with how git is installed and used with its URL. So please switch to bridged adapter and reboot the machine if you must. That will be important. Otherwise, it would seem to work, but then fail. And I can explain why. And in my case here, I'm just running it on bare metal. I have a Fedora, so it should be enough. So let's start by setting things up. It could be nice to keep this browser open on the KLab repo just to see what we're doing. So first, we want to make sure that we have some dependencies installed. There's a separate script for Fedora and for Ubuntu. And I'll just show you what it is. If you're starting from scratch, you do need this. It will install Docker. And I made a point earlier, almost all of this runs fine on Podman. If you have Podman installed, it would mostly work, except the KPT tool does require Docker, and it won't work with the Podman bridge. So unfortunately, it'll just be easier to run everything on Docker. So this installs it follows the installation instructors from Docker. An important aspect of the script is adding your own user. It will add your user to the Docker group, which is necessary to be able to access Docker without sudo. So yeah, I'll just show you how I'm running it here. If I try to run install, so I'm in the KLab directory, install dependencies, Fedora. right? I need sudo. Here we go. Oh, it's going to remove. I'm not going to. I already ran this, so I'm not going to run this myself because then I'll have to reboot as well. And it will tell you to reboot after, but it could be that just logging out your user will be enough just to make sure that the user is there. So let's all do this. And if you're on Ubuntu, there's a similar script for Ubuntu that will do the same thing, just the Ubuntu style. And it will also install some tools that we need to run some of the scripts, JQ, XGD utils. Those are not installed in Ubuntu by default. And yeah, you can see how much more complicated it is in the Ubuntu world than in Fedora. One of the reasons I prefer Fedora. So let's do this. And yeah, you might, as I said, need to log out and reboot. So it could be that you'll need to exit the Zoom meeting and come back in again. So yeah, give me feedback, everybody, on how you're doing with this, and you've reached the point where what you want to get. Go ahead.
Just running the script here in Ubuntu. It seems to be going fine so far. So
okay, good. Yeah, we want to reach a point where you can just access Docker in any way with without having to run sudo, and then we'll be good.
Yeah, usually you just have to just change the add yourself to this Docker, to the Docker group, and then it's good. You don't have to need sudo anymore.
Yeah, you could actually do this new group Docker and get into it as well. I think I tried that and it didn't work, but after I rebooted, everything worked. So it might be one of those mileage. Yeah, I think also when you install Docker, it actually doesn't start the daemon automatically. So oops, I think what I did here was in the script. Okay, I did do systemctl enable Docker, but I didn't do start Docker. So it could be that you can get away without rebooting just by doing system control.
Yeah, service Docker start should do it.
Okay, good. Yeah.
Sudo service start Docker start.
Yeah, service is a shortcut instead. That should also work. Yeah, so let me give everybody a few minutes. Is everybody doing this?
Yeah, it's just pulling down the world here packages.
Yeah. Yeah, the distros do have Docker installed in their repos, but I don't know. I went with the official Docker version just to make sure that everything is okay. Fedora does come with Podman out of the box, but as I said, unfortunately, it works most of the way, but for one command that we'll be running, we won't be able to use Podman. All right, meanwhile, I'll kind of tell you what we'll be doing. We're going to run, after we get Docker running, we're going to run another script called install tools, which just downloads the latest or approved releases, versions that I set of all the different tools that we're not going to use all of them. Again, this is my general Kubernetes environment, but it won't hurt to have them. It'll install Minikube, which you won't use, Kind, kubectl, OC for the OpenShift folk, KPT, virtctl if you're using KubeVirt, the cert manager CLI tool, K9s, which is a kind of nice dashboard, command line dashboard, Helm, and YQ, which is kind of, we're not going to use it today, actually. Yeah, we're going to use JQ, which is already in the repos. So yeah, if you already have that running, you can go ahead and run the install tools. Yeah, I have everything installed already. Yeah, we want to reach a point where we can do Docker PS. that seems to work. And we have kubectl, and that should be where we are. Could people chime in and just say if they have this working?
Yeah, Docker images, Docker PS working for me.
Yeah.
Still downloading and installing.
Oh, interesting. That it's
I
Yeah.
forgot to say -y, so periodically I have to type in
Oh.
y.
yeah. I didn't put -y on purpose because I kind of wanted people to see what's happening, but yeah.
Ooh.
Right, so I'll go ahead and explain what will be the next step. So what we're going to do is when everything is set up, I'm not going to run it quite yet, but environments, under environments, there's the config sync demo. That will be part one. Then we're going to do a Porch demo that kind of builds on this demo. And then there's a start script, but I want to show you what the start script does. We don't have to get into detail on debugging it. This is mostly automatic, but just to see what it will be doing. So it will start a kind cluster called two kind clusters, one management and one edge one. Just as a demo, of course, we can have more and more edges there, right? But in this demo, the management cluster has only one role. We're just going to deploy Git on it, which is our Git hosting. Git, for people who don't know it, it's an open source kind of mini GitHub that you can host yourself. Now, for this particular demo, you might ask, why are we installing Git on a management cluster? We don't actually have to. We could have just deployed Git separately and let config sync access it. But we're not using the management cluster here for any other reason. It's just hosting Git for us. But the you'll see in the next demo, we also install Porch. So I just thought to unify it and make it easier, right? Just to have everything in one place. But Git does not have to live on a management cluster. And probably in real environments, you're actually hosting Git somewhere else, right? Not inside your Kubernetes clusters. And that's kind of important too, because the edge cluster, the whole point of it is that it will have to access something from outside in order to get the resources. So you can see here where, I have some toolings. We'll use them too, that you can switch between clusters. And we're going to deploy Git from the workloads directory, and then create a user for us, and then create our repository for us in Git. So if everything, how are people doing? Can we move to this step?
Sorry, Tad. So the installation is complete. What was the second step you were mentioning?
Oh, so the second step would be running install tools.
Okay.
So yeah.
Thank you.
This should be pretty quick. It just downloads the tarballs from GitHub and extracts and puts the files. So this is a little bit destructive because it does put the files in user bin. But if you want to keep this virtual machine later, you can delete these files if you don't want them. But yeah, under user bin. But that's the only destructive thing that we're doing in here.
Done. Both the steps. Yeah.
Yeah. All right. So I'll assume we're here. So now we can actually start the clusters. So it's under environments. There's config sync demo. Start. And this is the trickiest step. What it's going to do is going to start. So you can see I'm starting the management cluster here. So that's just the script we were looking at. And it is using Docker, right? So that's why we need a Docker installed. So it's using kind to create that management cluster. And I'll show you some things about the configuration of the management cluster. So if we go here under KLab platforms kind, you'll see the cluster information. So the management cluster looks like this. So we are changing the kind configuration a little bit just to give each cluster its own range of pod IP addresses and service subaddresses. And for simplicity, using IPv4, right? But ideally, in our own FEO world, where I really hope we're going to focus on IPv6 first. But Yeah, so when you run multiple kind clusters on the same machine, you can run as many as you want. You do have to make sure that they just use different ports so they don't conflict. So this is why they're getting different defaults. Another interesting little thing here to mention is that we're opening node ports to access the dashboards. So here's the kind of Kubernetes dashboard, and here's the Gitti node port that we will also access. And it's for accessing Gitti, and also if you communicate over HTTP, it accesses the Gitti dashboard as well that we will use. So this is kind of a way in kind that you can open it. It's very easy to work with kind generally, right? It's declarative. You get this nice little KRM CRD that you can edit. So the edge cluster, yeah, here we go. It's just different range of ports, and it's not running Gitti, so we don't have to open the port there. Let's see how things are going here. Okay, everything started. Oh, in my case, so I actually did a little override here that I will delete, that I said I didn't want to use the browser. So I'll run it again. You can run this as many times as you want. It is idempotent. And what it's going to do now is you saw I just opened 3 pages in my browser with the dashboards. So that's what we want to get to when it finishes. So you see, right, you can see the URLs here too. So what it opened for me were, so one, this is kind of a simple dashboard to the management cluster. And this is a simple dashboard to the Edge 1 cluster. And this is the Gitti dashboard as well. This will be very useful for us. So just to show you the 2 clusters and what we have running. So this is the management cluster. We have Gitti, and there's not too much interesting to say here about it. By the way, is everything large enough for everybody? Can people see it okay? I'll assume so. So yeah. Good. So yeah, Gitti is running here. It uses PostgreSQL, Memcached. It has a few things. We don't have to care about that too much. It's just running. The Edge cluster is more interesting because here we installed config sync. And config sync has 2 namespaces. There's a monitoring namespace that we won't look at today, but the system namespace is the one we're going to look at. And by default, it has its reconciler manager for config sync. And then we have here the Gitti dashboard. So you can sign in with the administrator user, and the user is administrator and the password is administrator. And that should work, I hope. I'll give you guys a minute to get to this point. And meanwhile, I'll tell you what config sync actually is.
Could you just go back to the to your shell there for 1 minute, Tal?
Sure. So
Yeah.
What
I really
step?
hope it's
Sorry.
what?
After the install tools script, what else do we need to?
The command is environments config sync demo start.
Okay, thanks.
Yeah, because I had to do a quick reboot there. So,
Oh yeah, so just, the people following along hands-on, feel free to interrupt me and just tell me
No.
to wait.
Yeah, if you're using a server kind of thing, you will not have that server installation. You won't see this. The script throws some errors, but you don't have to worry about that.
Yeah. What error did you get?
No, it says platforms kind start failed and demo start failed, but I think that that's because of the web browser part and e-links, and those things are not available. But if I'm running a server, so
no, that it should work anyway, because I actually do check if the browser is not there, then it won't try to start the browser. So whatever error you're getting, it might be something else.
Okay, I will paste it in the Slack, Tal, for you.
Sure. Yeah. Let's see. Right. You should be able to run this on a server with no problem. You just won't see these nice dashboards. All right. Let's see what the.
No, I'm able to see the dashboard. I just need to go and.
Oh, I guess because we installed XDG utils. Right. If you want to very quickly fix this, you can edit. Actually, you can do this. You can create a file in the root called _override.
Okay.
And edit it and just add this, use the browser equals false. So it won't even try to use the browser.
Yeah, I got that as well. What's that file? Oh.
So the file is just _override.
Okay.
In the root of the repo.
Oh, okay.
And it's all caps, use browser false.
Yeah. It's just environment vars. So this is the environment vars. Use the browser.
Okay, so
false.
the file is a new file, is it? Yeah. So.
Yeah, it is a new file. It doesn't exist already. So yeah. There's a git ignore on this file, so it's not committed, but yeah.
Okay. Yeah.
So you can see here, for example, when I want to enable Podman, I can do it here. But
Anyway, Tal, I did that, but it didn't impact. I was able to see the browsers and all the components up and running.
Yeah.
See, I can rerun this. It'll open everything again. Okay, should I move on? What do you say?
We can rerun the same script, the demo script again. It won't have any impact. It's
So the
item
demo script is environments, config sync demo, start.
No, I was asking whether that script is idempotent. Can I rerun it again?
Yeah, you can run it again. Yes.
Yeah. Okay.
Seem to be moving along.
Yeah, it's plowing through. It's still here. Setting up the management cluster now.
Okay, yeah, it does take about 3-4 minutes.
Yeah.
So while that runs, I'll tell you guys what config sync actually is.
Fair
Yeah, sorry.
Go ahead, please.
Yeah, so config sync, it's an open source tool. It is pretty straightforward. The point of config sync is to let you put resources, KRM, into Git repositories, point clusters to those Git repositories, and config sync will make sure that your resource in that Git repository gets synced, continuously synced, reconciled locally in that cluster. So it's a deployment mechanism, right? And you can have many clusters, right? Use the same Git repository. They each can have their own, or they can share, and we can see you can mix and match things because you can actually sync multiple repositories, multiple namespaces, etc. It's kind of gives you building blocks that you can assemble the sync as you wish. So what we're going to see is like a few actually just one really simple example of how to do a multi-namespace syncing.
Azt írják, 90 percet. A piano azért, ez gyakran csinálja ezt a piano egyébként.
Somebody please mute.
Értem át, gyakran csinálja ezt, úgy értem, hogy sokszor van az, hogy késik. Ez nagyon sokáig szokott tartani.
Esteban, could you please mute your mic? Thank you. Okay, so yeah, let's see what we're going to do. So hopefully we all reached the point that GitHub is, Gitty is running. So if you log in with administrator, we can go here to site administration and then see the repositories. So we have just one repository created by the config sync developer user that was created in the script. And yeah, let's look at this repository. So the repository right now was created, but it's totally empty, right? There's nothing here. Yeah, I'll just note, some of the complexities with deploying Gitty is that it needs a nice URL. So the URL, it kind of goes through the host. This is something that can work in kind. It won't work if you're using something like Minikube, which is in a VM, because then you have to open ports, etc. But Kind makes it very easy because it just shares the networking with the host. So yeah, this is my own host name here, and this is the port. So this is the URL as well that I'm looking here. But this URL is also used, you can see here, for Git, for actual Git commands. Right. So now what we're going to do is fill in that repository with something. So I'm going to go here to environments, the config demo, and I want to show you the deploy script. So the deploy script is pretty easy. What it does is init the repository with some data, right? And we're doing this on the management cluster. So it should already be set up on the management cluster, but just in case, I'll show you how we can switch to the management cluster. We can actually do kubectl. Actually, I have a script that does it easier. So under, platforms, kind, use, and I can just tell it I want to use the management cluster. So I'm in the management cluster right now. So I can get all the pods in the management cluster. Good, right? You can see the Git pods here. So what are we actually going to init this repository with? So I'll go here to, under assets, here's the deployment repository. And the deployment repository has a namespace called, it has a directory namespace is under that network function. And I just put as an example, this is not a real network function, but I just put a single deployment, KRM, and it just runs Nginx as the container, right? So it's a fake network function, but I just wanted to show a workload, a potential workload. So a very, very simple workload, right? Just one deployment. And the important thing also is under root. Oh, yeah. So under root here, the root directory, I'm actually creating what is necessary for that deployment to be deployed, right? It needs a namespace, right? If I go back to that deployment.yaml, you see it's under the namespace network function. But who's going to create that namespace for me, right? I need this to be created. So config sync actually doesn't care about that directly, right? Config sync, again, is kind of these low-level building blocks. So I need to actually create that namespace too. So under here, I created this network function.yaml, which has a few resources. So here I'm creating the namespace. And then I'm creating a CR from config sync. This is the repo sync. So this is telling me that I want to sync from this repository. Right. So again, this will be filled in with our specific local data that you have. And I want it to sync from this repo under this directory, right? So this is a directory I showed you before with the deployment.yaml from this branch. And you can also add authorization. In this case, we're not using authorization because Git is created with everything is readable to the world. It's not writable, but it's readable. So they're public repos under Git. So we don't have to give it kind of any authorization. But if you're using a Git repository that does require authorization, there are a few different approaches to do that in config sync that it supports. You can use secrets with tokens, user password, etc. Anything that you need for Git to be able to access this repo and this directory, right? So now we can play around, excuse me, with directories and branches. So you can have a single repository that has deployments for lots of different sites, right? And lots of different aspects of that site. And you can put it in different branches. You can organize it by directories. You have quite a lot of freedom to decide what to do, right? But I will note what config sync will do will track the head commit in that branch, right? So if somebody commits something new, config sync will make sure to reconcile the new changes there, right? And we can play with that if we have time. The third thing is rather important. Actually, there are a few other things here important. So the name, So the repo sync CR exists in the same namespace, right? And it does have a name that is required. So it has to be called repo sync. That's what I found out through some trial and error. And there's only one repo sync per namespace too. I don't know if that could be configured differently, but from the example that I followed in config sync, this is how it worked. The third thing we need to do is a bit more complex to explain, but so we created a namespace and we want to put this CR into it, but how does config sync have access, be able to access our namespace to be able to put resources into it? By default, config sync does not have cluster-wide permissions. This is on purpose for security reasons, right? Because you might have different parts of your system are syncing different things, but you don't necessarily, you don't want to give them just carte blanche cluster-wide permissions to write everything, right? You want to make sure that these are contained. So for that reason, we need to give RBAC role specifically to the service account that will sync our namespace. So the name here is important, right? The service account here, this is how it works. So it has NS reconciler, that's namespace reconciler dash, and the name of the namespace under it. And then I'm just giving it a cluster role, which I don't have to do. This is just silly. Ideally, I would create a role just to write to this namespace, but whatever. For this demo, it's enough to just give it permission. I just want to make sure that it can write to the namespace. And we're going to see in a minute how all of these actually work live. So this is basically the whole repository. So to summarize again, I actually have my workload under namespaces. And then I have the root here for the namespace. So if I wanted to actually deploy multiple namespaces here, I could just create another directory with another namespace. And under root, create another YAML file for that other namespace that I have, which will look very similar to this. So you can just copy and paste this multiple times per namespaces that you want to deploy to. So let's say you have 7 network functions, each one in their own namespace. You would have 7 of these YAML files, right, that do the same thing for everything, create the namespace, create the repo sync CR, and give permissions. So all we're really going to do first by running deploy is set that repository. So I have a script that does this, and I just want to show you what the script is. So I'll go back here to, so under workload. So working with Git is not easy. This is actually the most complicated part of all these scripts. But here's the Git init. I just want to show you what it does, right? It puts things in a temporary directory and initialized Git with the main branch, configures the user and email that we set up already for Git, adds all the files, does an initial commit, adds the origin, right? So this is, again, with the username and password, and does a force push to that origin, right? And then deletes the file. So this is, go back to environments, config sync demo, deploy. This is the first thing that we're doing. This is this script here. So it's going to take that repo that I just showed you and just put it to Git. The next thing it's going to do is apply this rootsync.yaml. And that is the final thing that we need to do to tie everything together. So I'll show you this rootsync.yaml. So just a reminder, under the repository here, we created a CR called repo sync, right? And repo sync can be used to sync a specific namespace, right? And actually, to be honest, if you're using config sync, you could only use this. But because we have a rather complex place setup here that allows for multi-namespace environments, there's another kind of resource in config sync. So this is repo sync, but we are actually going to deploy here something called a CR called root sync. And root sync is kind of a higher level abstraction over repo sync. So it would allow us to actually sync lots of repo syncs in turn, right? So here we're going to the root directory, right? So we're telling the root sync to sync that root directory here. And again, that root directory from the deployment repository is this. So it will sync all of these. And then all of these in turn will create repo syncs that will sync their independent namespaces.
Okay.
Right. So we're going to run this and actually see what happens.
So it's a kind of a cascade. It's a kind of a cascaded thing. Then once you once you tell it to call the root sync.yaml goes into that root.
Exactly.
Whole,
Yeah.
Says, okay, I got all this stuff to deploy, and then it says, okay, I got these main things, and I got to go into each of the individuals and do it. Yeah, fair. Well, perfect.
Right. Yeah, there's simpler ways to do this. Like you can use only one of these if you just need to config one. But this is kind of the recommended way to sync multiple namespaces, which is, a very common use case. Usually you want to sync from, and you can sync them from different sources, right? Every namespace can come from different repositories, different directories and branches, etc. In this case, we're just putting it all in one repo, but it doesn't have to be one repo. I could probably have made this more complex by using multiple repos, but I wanted to keep things at least.
I know it's complicated enough for beginners.
It is complicated enough, right? So let's do this. So let's under environments, the config sync demo, let's run that deploy script. And I'm going to run it. And what it's going to do, that was very, very quick. It just created the Git repository for me. You can see it uploaded, and then it applied that root sync. So I'm going to show you. So I'm going to go back here to the Git dashboard. I'll refresh the screen, and you can see now it's filled. We have that repository exactly. This is exactly what I showed you before. So under root, we have the network function, right? So we can see the namespace and everything. And here the things are filled in. So we get, so this is the thing. The root sync is syncing from its own repository from which it came from, right? We put it all in one repository, but I want to emphasize they could have been other repositories, right? I could have had a separate repository for root and then a separate repository for each of the namespaces, right? But I decided to use a directory model here. So it's one namespace and, it's one Git repo and one branch for everything. So I can change like the whole deployment with one commit, right, to this namespace, to this repo. Sorry, and here under this namespace's network function, here I can see my deployment, right? That's what I actually want to deploy. So yeah, a lot of this is boilerplate, right? Because once you have this structure, you can kind of do it for anything, right? You can just copy and paste this, which is basically what I did. I copied and pasted from the config sync example. Let's look to see what's happening on. So this is the second dashboard that was open for the edge cluster, right? This is where config sync is running, and this is where we saw before the reconciler manager running. I'm going to refresh this page, and you see two more pods were created. Well, actually, two deployments were created here, and here are their pods. One is called root reconciler config sync demo, right? So this was created by the reconciler manager to sync my root repo. So this is the first one that I applied. So it created this, and the name is just root reconciler dash and the name of the resource. So the resource here under root, oh no, I was wrong. It's not, where did it get the name config sync demo? Let me think for a second. Oh, I think it's maybe the name of the repo itself. It could be the name of the repo. Yeah, I'm not sure where it got that name because config sync demo isn't mentioned anywhere here. So it must be from the repo name.
Sorry to bother you. So it's workload config sync deploy, right? That's what you wanted to.
Right. So it's environments config sync demo deploy. This here. Right. So again, what it did, it committed that initial repo and then applied the root sync to the cluster, to the edge cluster. Right. I'll show you again here the deploy. So it created the repo with our contents. It just did a single commit and just forced the commit to it. It switched to the edge cluster and then applied this to the edge cluster.
It did.
And let's take a look at this actually. So we're in the edge cluster now, so I can do get root sync. And our namespace is network function.
Do we need to switch the cluster tab before executing the command? Because we are in management cluster initially, right?
Yeah, that's okay. The first command should happen in the management cluster because that's where Git is. Actually, no, it doesn't matter. This doesn't require the cluster at all.
Yeah,
It
okay.
just does a local
No,
Git
but
commit.
it did
Yeah.
fail for me saying that some unknown option initial branch equal to main. Oh, I don't know whether we need to do anything additional. I don't know that others are facing the same issue.
Well, maybe just in case, make sure that you're really in the management cluster first, I guess. So you can do
I am in the
platform.
management cluster, yeah.
So when you ran deploy, what happened? You got an error?
Unknown option initial branch equal to main. I need to figure out what it is, but let me check it out.
Oh, it had some problem actually committing Git. Yeah, Git is very, very finicky. I'll tell you, most of my problems in setting this up was getting Git running correctly, right, with the URL. Okay, I'm sorry about that. I can try.
No issues.
Yeah, and I can also help individually after to get people running this. Try to help you debug your local issues. So yeah, I wanted to show that we can look at some resources here. So oh yeah, there was another important thing to point out. I know there's just so many little details, but the root sync has to live in the config management system namespace because it doesn't by default search in other namespace, so it searches in its own. So this is why here I have to go to config, wait, what is it? Config management system. Wait, really? It's called, oh, I switched to the management cluster before just to show you. So I'm going to switch back to the edge cluster. All right, there we go. So this is our, sorry, it's a little bit too big here. Anyway, we see it. I can actually, so it's called config sync demo. You can see it in YAML. And here it is. This is actually interesting because we can see, so this is the initial spec that I created. And you can see under status that it fulfilled lots of conditions, right? So you can see where the last commit, the head commit that it used, right? Sync completed. And you can see exactly what it's rendering. So this is very useful for debugging to see exactly what's going on. What is the source repo? What are the branches, the head, and what the status is exactly, right? So it's very useful to look at this when there are problems because sometimes there could be problems. But yeah, to go back here, let's see what it actually did. So the reconciler manager, if I go to the pod here and look at the logs, then we can see, yeah, it looked at that root sync, it found it, and started syncing. And the way it started syncing was creating this one, the root reconciler config sync demo deployment, which is config. This is syncing just the root reconciler. Now, once we started syncing that, right? If I go back to our, so it already succeeded syncing, but what it did was also create that repo sync, right? So, right, that cascading thing that Liam was talking about. It created that in the namespace that we created, which was network function. So here it is. Here's that repo sync. So again, what root sync did is create the namespace. and create the repo sync object inside the namespace, right? Because we gave it permissions, it was able to do that. So it created the repo sync object. And now what happened is that config sync managed to create a namespace reconciler, right, for that repo sync. So a repo sync results in an NS reconciler. And that NS reconciler reconciled that deployment for us. So I can actually go now under namespaces, and I have network function. Ta-da! It worked, right? At least for me. I hope it worked for you guys as well. But here's the deployment that we created. And here's that network function, right? It could be interesting to see a little bit the actual YAML that was created. So, you know, this was my original spec here down below, right? I just put the Nginx container image, but you can see that config sync added a lot of annotations too, right? To tell you, you know, who is it owned by, right? And it uses these annotations for reconciliation because it owns everything that it synced, right? Because if I do another git commit to that repository and change things, it will need to know what to delete, right? If resources are no longer there, and what to recreate and what to update, right? So it does all of that kind of, we can call it heavy lifting, but it's, you know, in Kubernetes, this is all just declarative stuff. So it's not too heavy. So really the config sync is not a very sophisticated tool, right? It really just copies, does git pulls, pulls git occasionally to see the changes and make sure to whatever comes out of there just to apply directly into the local cluster. Any questions so far? I know that there's, I try to go as slowly as I could through the details,
Hey,
but
Tal,
I'm sure.
well, I don't know, like, you have a the config sync overview tab, and there is like a diagram in that documentation. I don't know if
Here.
I don't know if we can use that image to correlate what you have been done. I mean,
Yeah, I mean, this is very high level, right, to understand what config sync is. But yeah, you can treat, well, you know, here they're talking about the different roles that you have. No, this diagram is not so great, I guess. But yeah, I wonder if there's another diagram here that would be better.
Yeah, I think it was more sort of kind of high level to explain to people to a black box, more of a view, you know.
Yeah, exactly. This is like just the first page to explain what config sync is, but you know, our point was to go beyond this and actually see how it works. So I'll summarize quickly because I do want to move to Porch as well.
okay, thank you.
That so what config sync does, right? It has a single controller. So I'll go back to config sync management system. Oops, yeah, here. So it starts off with just one controller that looks for those root sync CRs. And whenever it finds a root sync CR, it creates another deployment, another operator to manage it, right? I don't know why it was decided this way. I think the reason is because every one of these has a different service account, so it can have different permissions. So this allows you to kind of contain, right, different parts of the cluster to different parts of your organization that might have different permissions, right? So the reconciler manager does have, I think, cluster-wide permissions. No, it doesn't. Sorry, it only reads them in this namespace. That's why we had to create the root sync CR in this namespace, because this is the only namespace that it has access to. But once that was created, it created this extra operator running. And that operator was dedicated specifically to our root sync. And it had its own permissions, its own service account. And what it did, so it synced this whole repository. And this repository, sorry, it synced this directory in the repository. We specifically aimed it at the root directory. And in the root directory, what it did was actually create another namespace with a different kind of CR called a repo sync. And once that CR was there and it tracked it, right? The thing that tracked it is this root sync thing. It found, oh, I have a repo sync. So it created yet another operator to sync that specific repo sync. And it's this final operator, right? The third one in the list here that actually deployed our network function there. So, you can follow the documentation. It's actually excellent for config sync. It's all public. And hopefully with what I gave you so far, it can help you explore more aspects.
Would you mind just clicking back to the Gitty window for 1 second, please? I just want to get the URL.
Oh yeah, so this URL is like specific to me because it has to do with your host name.
Oh, right,
yeah, but the port is 32,100.
Okay.
So if you just go there,
actually,
I mean, it'll take you.
yeah, I got it. Yeah, that's great. Thanks. Because I got I just got the browser up there off the VM when you were.
Yeah, and if you want to see all the clusters, it's useful to go to site administration. Sorry, all the repos, and then you click the repositories tag, and you can see everything there. All right, guys, I'm going to move to the next demo. I know maybe not everybody got on board, but let's move to Porch as well. Let's add Porch to the mix. So I'm going to
before you go, if I may ask you one question.
Yes.
So in the repo that you showed, where it said the root sync, where it creates the second operator, how I don't know whether I missed it, or did you show exactly what the deployment was in that repo?
Yeah, so the deployment is really just this thing, just one resource. It's just called deployment, and it just has a single container with Nginx. I'm calling it network function just to for us, but it's just running an Nginx image. So
basically, whatever is there in that directory, so let's say there are 10 resources, it's gonna sync all of them. Yes, right. That's important. So that's a good question, because if I go back under here where I actually created the root sync, sorry, the repo sync, it gives it this directory. So everything under this directory will be synced. So you can have 100 files there if you want. Okay. Yeah. Right. So it's in this directory, in this repo. Now, in this case, they just happen to be in the same repo. Just I created 2 directories, one for the root and one for the namespace, but it could have been a separate repo. You could have a separate repository for every namespace that you want, or have the same one with different branches, right? It's kind of up to you, your own strategy of how you want to organize Git. Right? You can have everything. You can have your entire network all in one repository if you want, with different directories, different branches, etc. It's kind of up to you and how things work in your own organization, right? Okay. So yeah, it's a little bit clumsy. I can see that here, but the reason it's clumsy is to give you that flexibility to organize things as you want, right? Instead of saying just point here and synchronize everything, you can actually control what to synchronize into which namespaces and from which repos and with which user service account, right? The role binding here is important too, because you can actually tell the operator, control which permissions it has, right? And it could be very fine grained. You can say that I only want this operator to create deployments, but maybe not touch some sort of CR that belongs to another operator running in the namespace that has different permissions, right? So yeah, the reason for all of this stuff is just to give you control. But it's also very boilerplate. Once you figure out your strategy, you just copy and paste these things, right? And not only that, I mean, you can create, this is all KRN, right? You can create a higher level operator that manages this as well, that creates all this for you, right? So you can have some sort of general sync operator, which has its own CR that's like designed specifically for network functions. And you can give it whatever information you want, and it will generate all of this for you, right? It could create the Git repo, it can create with all the content in it, etc. Right? So this can be the final point of your toolchain, right? So if you have some sort of a higher level orchestrator that orchestrates your entire fleet, 100,000 sites, right? You might not want to do this manually for each, of course. So you might have something that generates all of this for you.
right, from some sort of higher level, right? So yeah, it's, you know, the power that it gives you here is that you do not have to communicate directly with your edge clusters, right? The only thing you really need to do is install config sync there and apply a root sync, right? That's the only thing we needed to send was oh, sorry, I'm here. This root sync, right? And that instigates everything. So it allows for an indirect way to get resources right to your edge clusters, right? So it's based on pull rather than push, right? Instead of having direct access to all your edge clusters, the edge clusters pull from repositories. Now, a good question would be here then, well, this is only part of the architecture, right? Because how do you actually know that they succeeded, right? If you're not talking directly to all your edge clusters, there must be some way to find out that everything was actually deployed successfully, right? You don't even know if the edge cluster is up or down, right? You assume it's there and it's syncing. But yeah, so that's not what we're going to talk about today. Config sync is really just this, you know, Unix philosophy. It solves one specific problem of getting the resources there. In terms of monitoring and other things, well, those will be other components. And a little bit foreshadowing, in the Google seed code for Nephia, we will contribute a component that can close that loop, right? And let you know what actually happened in the edge cluster. So you can be sure that things were deployed and how they were deployed. All right. So the first hour is complete. I want to move on to the Porch demo, just because lack of time. And, you know, as I said, I know this was a little bit fast. Try to go as slow as I can, but feel absolutely free to run this on your own. Contact me for help or questions, and I can try to debug specific things in your environment. And this workshop will also be repeated in the future for another time zone. So if you're enjoying this, you can repeat the wonderful experience again. If you will feel more ready then. So what we're going to do now is going to tear down our current environment. So under environment, config sync, we're going to run stop. So it'll just delete these two kind clusters. And that's it. We basically tore down that entire environment. Now what we're going to do is switch and create the Porch demo environment. It's similar in some ways. It builds on this one, but I will show you what we're doing there. So I'm going to go under KLab environments here and just show you the Porch demo, the start for it. So it's a little bit longer. It starts in a lot of the same way. We have two clusters, management and edge. And we're deploying Git again. This time we're going to create two Git repositories. One of them is going to be for deployment. And that is very similar to the repo we just saw in the config sync demo. That is, that repository will be ready for the edge cluster to sync from. So config sync will be pointing at this repository, our deployment repository. But we're adding another repository that I'm calling here the blueprints repository. And we'll explain what that is a little bit more. And I'm initializing these two repositories with at least one commit. Here's a little note here. Porch absolutely requires the repositories to exist with at least a commit. So it's not enough to just create them on Git. We actually have to have at least one commit in them just so Porch won't error out. And then we're also deploying Porch on the management cluster. So this is a little bit different. The previous environment, we had a management cluster that didn't really do anything. All it did was host Git for us, which we could have hosted elsewhere too. In this case, we actually do need a management cluster because Porch runs on Kubernetes, right? And relies on Kubernetes very much. So, so we're deploying Porch there. So now we're really using the management cluster as a true management cluster, right? The previous environment was not that. And in this case, I also need, because we're not only reading from the Git repo, we're also writing to the Git repo.
So I have to create a secret so Porch will be able to write to the deployment repo. So here we're also doing kubectl to create a secret for gitt. And yeah, the edge cluster is exactly the same. We're just deploying config sync, right? So I want to show you all these things that I'm actually going to be deploying there. And meanwhile, if you want to get this running, you can just run this environment Porch demo start. It can run in the background. It'll, again, take like about 3 minutes to run, I think. So what are we actually putting in these repositories? And what is this Porch repositories.yaml that we're applying? So if we go here under assets, so here is, I'm going to start with the blueprints repository. So the blueprints repository, oh, it just starts empty. Yeah, I just needed an initial commit for it. So it just has a README. Okay, that's fine. The deployment repository. Oh, the deployment repository. Oh, sorry, it's opening all my tabs again. All right, you don't want to do that. So the deployment repository root, it's exactly the same as we did before with the config sync demo. So again, but I'm putting 2 namespaces this time. So I'm extending what we did before. So before we only had, I told you it's a boilerplate that you can just copy and paste. I just copied and pasted. So here I have network function A, exactly the same as we saw in the config sync demo. Exactly the same thing. Here's the repo sync, and here's giving permissions to the service account. But all it does is have A at the end. And then I copied and pasted and created another namespace, network function B. So it's the same thing. You know, it has a different directory. Oops. Yeah, again, it's opening all the tabs. But yeah, it has a different directory under the repo, but it's the same repo. So it's one deployment repo, but it's going to have 2 namespaces to deploy in it. One is called network function A directory and one network function B. And then here's the root sync, the same as before for the edge cluster, and it just syncs root. So this is the same again. So again, this is the same config sync we saw before, exactly, except that it has 2 namespaces instead of 1. All right, everything was open. And the addition here is this YAML that I am applying as well, the Porch repository. So here we're introducing a new CR that we haven't seen before, and this comes from Porch. The CR is called repository. And you know what? It looks a little bit similar to the root sync we saw in config sync, right? Because again, we're just giving it a repository, a directory, and a branch. But there's more stuff that Porch does with this, right? So it can actually support other kinds of repositories, not just Git, but we're going to focus on Git today. I have a flag that I'm saying that this specific repository is our deployment repository. And I'm creating another repository here for our blueprints repo. So I'm creating one CR per Git repository that I have, right? I have 2 Git repositories, one for deployments, which will be synced with the edge cluster, and one for blueprints. They're configured in very similar way. I'm giving the same secret that I gave before, so they can actually have write access to these. So Porch can have write access. The only difference between these 2 is that one of them I'm setting deployment true, and one of them I'm setting deployment false. But otherwise, they're structured in exactly the same way. They're both contain packages. And really, from Porch's perspective, they are almost identical. The only difference is this flag, right? And that's an important thing to point out. The Porch primitives, the fact that one of these repositories I'm treating as a deployment repository is kind of outside the scope of Porch. Porch doesn't know that there's config syncing with this repository, and it doesn't care. Porch only deals with repositories and packages. Okay, I'm simplifying things a little bit, but I think you get it. Oh, and just for fun, I added one more repository that I called external blueprints that points to our Nefio project repository, just so we can see it. And we're not actually going to be using it, but just to see what happens. So all of that was created, right? So we applied these, and yeah, we won't be able to see them in there's not much to see here. Oh, in Gitty, we can see the two repositories. So again, I'm going to log in administrator.
Hey, Todd, by the way, I guess that you can access to the repositories just clicking the logo in the left corner, the green logo.
Oh,
Over
this? Okay, thanks. Yeah, but these are only my repositories. I'm an administrator and they're repositories created with a different user.
Oh, okay.
So that's why I'm going to site administration. It's not the same. Yeah, because I wanted to prepare this to build on this so you can actually create different roles with different users and different permissions for different repositories, right? So here I'm logging in as admin, that I can see everything. So here are my two so here you can see the owner is actually Porch developer. I'm logged in as administrator. So here's the blueprints repo, which just has a README. And the Edge repo, Edge1 repo is, you know, very similar to before. I just have a root directory with the two network function things. But you'll notice I don't actually have any packages, right? That's very important because we're going to deploy packages. We're going to use Porch to actually deploy packages to this repo. All right. We're finally at the fun stuff. So the Porch demo README goes over a lot of this in depth, right? This gets pretty complicated, but I want to kind of show you a little bit what we have right now. So I'm going to switch. Let's see the repositories that we just created. So I'm going to switch to the management. So I'm using this just to copy and paste. So to make sure I'm in the management cluster where Porch is running. And let's look at all our repositories, right? Here are the three repositories that I created, right, in that YAML file. So there's the blueprints repository. You can see deployment false. It's ready. And this is, right, this is the address of the repository in Gitty, my local Gitty. I have my Edge1 repository, which is deployment true. And then I have those external blueprints from the Nefio project. Right? So interesting, you know, I created a namespace here called Porch demo where I put it all in. This is, to be clear, this is a management cluster namespace. So, you know, if I'm working with Porch, I can create multiple namespaces to deal with kind of different projects that I'm dealing with, right? So every project can have its own set of repositories, right? So, yeah, so namespaces could be used for kind of a multi-tenant solution, maybe for Porch, right? I imagine that in many cases, one namespace will be enough. You just put a lot of repositories in that one namespace. Right, so I have Edge1 here. We can add Edge2, Edge3, etc. So I need to create these CRs to kind of link Porch to that repository. And I'll point out again, you know, a single Git repository could actually be used to deploy to 100,000 sites. Right, because it's all about my strategy with a config sync that I had before, right? So I can have 100,000 sites that are all syncing from the same repo. So I don't have to have a single repo per site, right? There's a lot of flexibility in how I want to do that. I can use branches, directories, etc. if I want to differentiate between the sites. But, you know, in this case, I just have one deployment repository. Yeah, there could be several. Okay, so those are my repositories and that I've already created. And I do want to mention here that we could use kubectl for a lot of this, but you also have the kept tool installed. And the kept CLI is really used for two things. It's used for dealing with kept functions and packages, which we're going to talk a little bit about, but we won't go too much in depth into that. But what we're more interested in this workshop is Porch. And to access Porch, it's currently in alpha. So there's an alpha command. And under alpha, we have access to the Porch stuff. So there's a repo, R package, which I think means remote package. I'm not sure, or repo package, and syncing. So here are some tools to interact with Porch more directly. We could do a lot of this using the kubectl command as well. And I wanted to kind of show here that we don't absolutely need the kept command. So the same command that I just read, you could also use kept alpha repo get and just give it the namespace. So it actually does exactly what I just showed above. So So this kind of kubectl get repository, it's exactly the same thing. You can see it's exactly the same output. So the kept command is just kind of a helper to do things without dealing always directly with the CRs. Okay, now we get to what Porch is actually doing. Okay, so we set up Porch. We pointed Porch into these 3 repositories. Porch is going to pull these repositories and look at the packages they're in. For each package, each kept package that it finds, it's going to create a CR for it called package revision. And also next to package revision is a twin resource called package revision resources. And I'm pointing out here something very important. Package revision is a real CR. Package revision resources is not a real CR. It uses API aggregation to kind of access the resources directly. And this is to avoid flooding, because imagine like you're pointing to, I don't know, 10 different repos. Every repo has 1,000 different packages and different versions of each package, right? It's called package revision because every version of that package, every revision of that package gets its own CR, right? So if you have a package called free5gcupf, and it has 3 revisions, all 3 revisions will have their CR created. And each of them will have a matching package revision resources that you can actually access the contents of the package from the Git repo. So let's see how this works. So first I'm going to show you the kubectl way to get it. So we can look at that namespace and you can see what Porch created for us. So right now, our 2 repos are empty, but the external repo, the Nefio repo, already has packages in it, and you can see them. So here are the package revisions that it found and created. So Porch created these for us. It gave them each like this GUID based on the repo in which it was found. So we have a free5gc operator, and actually it has, so it actually does 3 things, right? There's a version 1 and a version 2 revision. But also the main, the current head gets its own revision too. So it's not tagged. We're going to talk about tags and how they work, you're going to see. But we can see that it created those. And here we only have 1 version. So there's v1 and then main. There's also a flag for latest. So you can easily search and find the latest one. And you can see its life cycle. So all these revisions were packaged. This is actually just 2 packages, right? free5gc operator and free5gc upf. But for each package, we have 2 revisions. And at the very minimal, you'll have 1 revision if you just have main. And if you tagged a version, then you'll have another one for the tag. Right? So these are CRs that Porch created for us. And they're going to change, right? Porch is continuously monitoring those repos and will create new CRs, et cetera there. And it goes both ways, right? We can create a CR here and Porch will sync it with that repo. That's where it gets powerful, right? So that's what we're going to do. And again, the kept command can also you can use kept alpha R package to do exactly the same thing. So I'll just show you here that it works. Exactly the same output, right? So you can use either command, whatever you prefer. To see the contents, so now I want to see the actual package revision resources that are associated with each of these blueprints.
So, Tal, if I may interrupt you, so since you show all these packages from the Nefio repo, just for the completeness, is it a good idea to just look at that repo and how it maps to this list here?
Oh, we're going to create our own blueprints too. So
Okay.
Yeah, don't worry. I'm just showing you the initial state when we didn't do anything. We're actually going to create a deployment. We're going to do the complete end-to-end of actually creating a blueprint, mutating it into a package, a deployment package, and seeing how it's actually deployed with config sync.
Okay.
So, but I'm starting just showing you the basic primitives, right?
Okay.
So package revision is probably, I think, the most important kind of base resource in Porch, because these are actual packages, right? So I have a few commands here to get the package revision resources, and I'm sorry it's a little bit complex because so I have this helper command that I created, workloads porch package revision name, because I want to get the name these are the names, right? And the names have these GUIDs. So the names themselves aren't very informative, but I want to kind of search by specific things. So I'll show you just how the script works so it won't be completely mysterious to you. So under KLab, workloads, Porch, I created this script called package revision name. And you can see behind the scenes, it does kubectl get package revision, but it uses a field selector to search, by the package name, repository, and version that I want. And then it'll output just the name of that thing. Right, so this script, it has a few different ways. You can give it draft if you just want a draft version. And we're going to talk about drafts in a bit. So it has a few ways to search according to what you do. But it's all just kubectl get commands with field selectors. That's basically it. So you can like filter and find exactly the package you want. So going back to the environments, Porch demo. So yeah, this is what I'm doing here. I'm getting the blueprint name. So we're going to get so the namespace is Porch demo. The repo is external blueprints. And this is the name of the blueprint. And I'm not giving it a revision. So it means I'm just asking for the latest one. So if I run this, it's just this first line here in Bash, and I do echo blueprint. Yeah, so it just got the name for me. So it's this name here. So it just got the latest version of the free5gc operator in the external blueprints repository. You see the flag here is latest true. That's what it just searched for. So that's just a shortcut to give me the name. But we're all using command lines, right? And Nefio, again, just like config can have a higher level orchestrator, right? Nefio will do, you're not going to interact directly with Porch in R1. We have controllers that will do this for you. So you'll be doing this programmatically, of course, not from a command line. This is just us learning it from a command line, right? This should be automated, right? At a higher level. So now we have the blueprint name. Let's actually get the package revision resources for that blueprint. So the way it works that every package revision CR has a twin, as I said, package revision resources that has the same name as it. And yeah, let's just get this. Actually, I'm going to do kind of a small version of this. I'm not going to get the whole command here. And I'm just going to output this as YAML. And I'm doing this on purpose. Okay, what did we get here? We got kind of a very long thing. I'm going to have to scroll all the way to the top. So again, this is not a CR, right? It's KRM, but it's not a CR. Basically what we got here, so here's the kind, it's package revision resources. And this is the package name where the repository came from. And then we get the complete contents from Git, right, of the package. So here are all the files, every single file with its contents in YAML, right? This is the package. So basically what Porch allowed me to do is within, right, all I'm doing here is using kubectl commands. So I'm in a management cluster. I'm using 100% Kubernetes here. I'm not even using the kept command. I'm using kubectl. Porch basically allowed me to access all the packages I have, all the revisions with their contents in the in Kubernetes, right? So it kind of acted here as a bridge between the GitOps world of repositories and Kubernetes. And the real powerful thing that it's a two-way bridge, right? So if I change these package revision resources, I am able to actually, if I change the content of any of these, I'm able to mutate that package, right? And that's what we're going to do. We'll kind of indirectly. I'll show you how we're going to do it in a bit. But I want to make sure that this is kind of clear. So Porch created these CRs for us, the package revision CRs, and each one has a twin, which is package revision resources, which includes all the content. Right, and actually, this is something that's definitely easier using the kept command, because the kept command will do this very nicely and just give me the contents as an array. So it doesn't actually have the file names and everything like that. So this is 100% KRM. I can actually apply this, right, if I want. This is just pure Kubernetes. Yeah, there's another tiny point here, a bug that I opened. Because package revision resources, when I do the kubectl get command, I'm actually interacting. kubectl just normally interacts with the Kubernetes API server, right? The Kubernetes API server has a maximum limit for request size. So if the package is very, very big, it would have to be very big indeed, then it will error out. I don't think the kept command has that problem, because the kept command doesn't, it accesses the API server directly, so it doesn't go through the kubectl API server. So, but that would only affect very, very big packages. And I think there are ideas in the Porch community on how to solve this problem in a different way. But yeah, generally, this is using kubectl, but if you have a controller, say a Nefio controller of some kind running in the management cluster, it can interact with Porch directly with a published API library. So there's a client API library, and you can do all these things programmatically, right? All right, let's actually use Porch. So far, we just set Porch up, and it created, it scanned the external blueprints, but our blueprints repository is empty. So we have this create blueprint script. Go ahead. Somebody.
Sorry, no, I didn't realize I have no use.
Sorry. Okay, so now we're going to run this create blueprint script. And it's not very long. So what it's going to do is we are going to use the kept command to create a new package. So that's our package init. We're going to call it network function. We have to tell it which repository to go into. So it's going to be our blueprints repository. That's the repository CR that we created. The workspace is, at this point, this is going to turn into the revision, but at this early space, we're just creating a draft, so we don't have any tags. So we're calling it a workspace, right? Because we're still working. It's going to create this package in what's called draft mode, which is the most basic way to create a package. A draft package is just created. It's not published. It shouldn't be accessed in any other way, right? But this is the first step in the life cycle of a package, creating it as a draft. I'm putting it in this namespace, right? Because this is actually creating a CR for me. This will create a package revision CR. And yeah, we can run this step by step. So you know what, I'm gonna just copy it and paste this because I want to kind of go one step at a time. I mean, you can run this whole script, create blueprint if you want, but I just want to kind of do this. So I think the Git blueprints repository is just called blueprints. Let me just verify that I'm not yeah, it's just called blueprints. So we were here under create the blueprint. Okay, so this will create, I'm going to run this. I can see echo blueprint. And now if I run the command from before that got all the packages, you can see that it created another package revision for us for the package we just created. It's called network function. Here's the workspace name v1 that I gave it, because I want to work on the first version, right? It is in draft, the lifecycle, and it is in my blueprints repository. Right? Let's see what happened on Git. So if I go to the blueprints repository on Git, looks like there's nothing here, right? Not exactly. There's a branch. It created a branch on Git for me called draft/network function/v1. So it's a draft branch, right? That's how I started. This is the name of the package, and this is the revision that I want it to have eventually. And if I go here, now there's more in this branch. So I actually have Yeah, so what it did, it created a draft. So Porch created all of this, right? It created a kept file, which this is kind of metadata. It's more than metadata, but let's right now call it metadata about the package itself. And we have a README that created for me, tells you how to use it. And it created a package context.yaml, which just has a config map. So it really, this is just a template that every draft package gets, right? Now we can work, directly with Git to edit this package, mutate it, do whatever we want to it really on this branch, right? We can build on this current template that it created, or we can overwrite this with something entirely different. It's kind of up to us. So it just created some content just to give it something already there. So that was actually one of the biggest things we've seen so far, right? Because I created a CR, and magically it created a Git commit for me, right, on a branch, right? This is the heavy lifting that Porch does, right? So far we were just doing a one-way street showing how it creates resources by scanning the repositories, but now we actually made a change to the repository. So that's why it was also important that we had to give it credentials, like that secret for authorization, so it can actually make commits on this repository. It needs permissions on Git, of course, to commit to there. It also, we would also have, I forgot the command exactly. It also created, so it created the package revision resource for us, and it also should have a package revision resources, right? So I can do an rpackage pull command, and I can use the name here from before for the blueprint. Yeah, and this is the contents. It doesn't show me the README. It just shows me the contents of here's the kept file resource. It just shows me the KRM here, right? And that config map. So yeah, they just created an empty draft for me. So what are we going to do next? If we go to create blueprint, now I want to push content into that package. And by pushing, I'm going to overwrite that whatever was there before. I don't care about the template that it just put there. It's you can build on that if you want, but you don't have to. Usually you have content that you already want to put there. Since we're creating a blueprint, we have a directory here with the content. So I want to show you what's in there. So it'll be here under assets, blueprints, network function. So yeah, here I already kind of modified that README a little bit. And the kept file, here I gave it a little description, network function blueprint. So I rewrote the kept file from scratch. And I created a deployment YAML, exactly the same as before. Remember our silly deployment YAML from the config sync demo? So here we're, it's just Nginx again. It's exactly the same one. But notice a very important little thing here. I didn't give it a namespace. All right.
This meeting is being recorded.
Hi, we're continuing the workshop from before, so it'll be a two-parter on YouTube probably, unless somebody wants to edit the two videos together.
Maybe you should just start again, Tal.
Yeah, I'll just restart. Well, I will start again because we'll probably repeat this workshop. Third time's a charm, right? The third time it'll be awesome. So the important thing I wanted to show here, the difference. So this deployment.yaml is very similar to what we showed in the first demo, except it's missing something. It's missing the namespace. And that's a very, very important detail because this is a blueprint. It is not quite ready for deployment. To make it really ready for deployment, it needs that namespace to be added, right? And this is a very, very simple example, but when we talk in Nefio about hydration and what that means, it's basically taking something from dry, which is this, to wet, which is actually something running and deployed, right? So here we're missing something very small, but we can miss a lot of things. We can miss IP addresses that require an IPAM injector to put in, right? We can miss network attachment definitions that we might have some shift left approach where we want to actually put them into the deployment. right? We can have all this vendor specific stuff that we'll need to fill in. So in this very dumb example, I just showed you that the namespace is missing. But I think you can imagine that a lot of things could be missing that need to be filled in when we take this blueprint to become a real thing that's deployed. So that's what's very important here. You know, I'm creating a package, but this package is not ready to run. It's specifically designed in a way that it will need to be modified in some way. So if we go back to the script, so it's the create blueprint script. So here I'm pushing the contents of that directory to the blueprint. So I'm going to do this again manually. I mean, you can run this whole command. I'll just do everything, but I want to show you step by step. So again, we have the blueprint and we have the contents here, the directory. Oh, sorry, I missed a K. Oh, it's under, sorry, I have a directory structure here, environments, Porch demo. Okay, here we go. Okay, what it did, so if I go now to Git and refresh, it shows me the new content that I just pushed. So that's exactly that. I have my new README, my new ket file, and here's my deployment.yaml. So that's exactly what I just showed you. Right, here's the metadata, the name, and there's no namespace given. So yeah, and it's the same branch, nothing changed, right? So when I do kept R package push or kept alpha R package push, you know, I'm just pushing the contents directly there. It's not changing the life cycle, right? If I go back to kept alpha R package get, just to show me all of them, I won't see any difference here. You know, it's still workspace v1 and it's just draft. All I did was change the contents of this this specific package. But yeah, it actually happened on Git, so it's real. Something real actually happened. What's the next step? The next step I want to do is, so Porch gives you a life cycle, and we can talk about why the life cycle is, but there are a few steps that you can have here. So we're now in draft mode, but I'm going to move it, the life cycle, to propose mode. Sorry, the propose phase and the life cycle. So it's very simple with kept. I just need to give it a command.
Sorry, Tal, would you mind just come back to the console for a minute? I missed the last command a minute.
Sure. So yeah, I mean, you can actually run. I know I'm doing it step by step because I want to show you all the pieces, but if you want to run all of this, so under environments, Porch demo, you can just run create blueprint. That'll just do everything. It'll create the draft, push the draft, propose it, and then approve it. So I'm just doing this. Yeah, if you want to see my command, I just kind of, sorry, this is the command here. Let me post it to the chat as well if you want to follow this extremely directly. Yeah, I can probably improve this and make sure that
that's great. Yeah, I just have to, I'm in the wrong direction.
Yeah, feedback to myself to improve that and show people exactly which commands to run instead of all at once. So now I want to do the propose. So I just need to propose. I just need to give it the package name that I want to propose. It was proposed. Okay, something very important happened here. So you see from before, I'm not going to refresh it. We have that branch, which is called drafts network function v1. I'm going to refresh right now. It's gone. So that branch was deleted. And what we have instead, it was merged into main and tagged. And I'm not going to get into it, but Porch has a few different strategies by which it can do this proposal. There can be various kinds of merges that you could potentially do. So you have some control over how Porch will do this for you. I apologize. Let me turn off my phone. So, but the default is to do that. It took my branch, merged it, and tagged it. Notice that the tag right now is proposed, right? Before it was a branch called draft. So the reason it was as a branch is that I can do anything I want in the branch and change the head. I can do all kinds of changes. So what I'm doing now, because I actually proposed it, it is merged. It is no longer a draft, and it is tagged on main. And this is an extra step before actually deployment, because it gives you some, it allows for another role to come in and somebody to actually see this proposal and then approve it, right? So to see what the changes are. And now that it's in main too, that you can do a very clear git diff and see the difference between, you know, the current head of main, what is actually, you know, there, and what was the change that you made, that tag, right? So you can do a, yeah, go ahead, John.
Yeah, no, this is interesting. I actually never dug this deep. So you're saying it merges it into the main branch, but it doesn't change the head of main. I'm confused. Like,
well, it will change the head of main, but it will also
when you
tag that,
approve. Okay.
right? Because you know, you can have
No,
100 different people working on this Git repository at the same time, right? So,
right.
so yeah, I don't know how the merge exactly happens and what happens if there are conflicts. You would probably know more. But yeah, there could be different tags at different places from different people, right? From different people.
But right now, but that would imply, I'm a little confused, because that wouldn't that imply that if we have a root sync that's pulling main.
Oh,
that would-
let's ignore the deployment repository for now, but you're right. I do have a lot of questions too. Not everything is 100% clear, because what you asked is exactly the case. You know, what happens if somebody else pushes another blueprint here? So the organization is good because every package gets its own directory. Oops. So, you know, if I go to that, oh, you're actually right. You're actually right. Sorry, I was wrong. The main branch doesn't have that package yet. It's a tag.
Is it a tag or a branch? I guess is the question.
Oh, wait, sorry, I confused you. No, you're right. We're still a branch. It renamed that branch.
Okay, that makes more sense. Yes, that's what I thought. Yeah, so there's a proposed branch.
I thank you for this. Yeah, I'm just clicking too fast here, and I'm looking at the time and trying to move fast. No, you're absolutely right. We just renamed the branch. That's all that happened yet. I jumped ahead.
But you are right that when we do publish it, we tag it.
Yeah, yeah. So all we did was rename the branch. Okay, that's the only thing that happened. So the new name of the branch just tells us that it's a different phase in the life cycle. But because it's a separate branch, we can still do changes there without affecting the main. So you're absolutely right. I confused. So really, proposal is just another phase of draft development. It's very similar to draft. It's just kind of upgraded the, you know, it can change the roles in the organization that deal with it, right? So sorry about that. Yeah, thank you for catching that. That was a very important part of it, actually. And actually, in the README, I do describe it correctly. I just, if you go through the README, it'll tell you exactly what happens when you propose the draft. Our Git repositories branch has been renamed to this. Okay, good. So I'm not completely crazy. Now what we're going to do is publish the draft. So it's pretty simple in terms of the API. We just do approve. So if I go back to the get, right now, the network function changed to lifecycle published, and it's the latest version. And it also got a revision, right? Before we had just the workspace name, but now it's actually a revision. So it's no longer just a branch area that you can work. It's actually published and tagged as that. So now if we go and refresh here, now it's really gone. This is what confused me before. I refreshed and it was gone, but I didn't realize, no, it was just renamed. So yeah, now the branch is gone. There's no other branch. It's just main, and we have a tag. And the tag doesn't have any prefix. This is just our package, right?
And just sort of as an aside, I'm sorry, maybe we don't have time for this one. If you're manually mucking around, you have to do this tagging yourself if you're not using the Porch to do the publishing and life cycles. But if you tag a package name /v1 following that format, v2, v3, Porch will pick it up as a revision.
Yeah, I assumed that was the case. I actually tested that. Yeah, one part of it. Right, it's a one-way street. Porch makes sure to reconcile everything between the Kubernetes world and the Git world here, right? And I imagine it does so very successfully. I will say another thing, and I'm presenting this very neutrally. I'm from Google, but I'm just, with no philosophy, just how everything works. The code base of Porch is very well written, very straightforward, and it's not a lot of code. You see here, there are a few primitives that you need to learn what they do, but in terms of what's actually happening behind the scenes, it's all fairly straightforward, right? It's really kind of bridging the declarative world of KRM with a kind of more operational world, imperative world of working with Git, right? So, and yeah, the reconciliation works both ways. I'm sure there are edge cases that won't work, but we won't get into them. So yeah, our blueprint was published. And right now, if I look at it, our new blueprint is exactly the same as all the blueprints that came from the Nephew repository, from external blueprints. It's just a different repository, but it looks really much the same as all the others. All right, let's deploy it. So to deploy a blueprint, there's another script. Oh, oops, I think I just had a bad link here. So here is deploy blueprint. Now, in the interest of time, I do want to get to something else. So we are gonna, no, I should really go through this slowly. So this is very similar to the previous script, but the difference is that my new deployment package that I'm created, so this part is exactly the same as before. I'm using our package init to create a new package. This time it's in the deployment repository, right? Again, from Porch's perspective, the fact that it's a deployment repository doesn't matter. It's just another place to pull and push packages from, right? So I'm, again, initializing the package, pushing content to it, proposing it and approving it. The difference here is that what I'm pushing is going to be first pulled from my blueprint. So remember, the R package pull command gets the whole contents of that package, right? So here I'm getting the package name. This is the package that I just created, right? I'm pulling its contents into a directory, a temporary directory. And then I'm doing the mutation. So this is the only part of kept really in this entire demo. I am using the kept command to run a kept function on that directory. And this specific function is called set namespace. So I'm not going to delve deeply into kept today, right? This is about Porch. But I will say that what kept does, and I know, we already had a lot of introductions from John on this, but I'll very, very briefly just summarize. Kept is a way to run these, what we call kept functions that are just container images, right? But these are container images with a specific set of inputs and outputs. And their job is to mutate packages. So I'm telling it what I want to run. And if you look at the, here's kind of the Porch guide and the documentation. Here under reference, oh, here, function catalogs. So these are a lot of the published public kept functions. And I'm using this one called set namespace. And yeah, a lot of them are kind of these general purpose things to manipulate KRM. Like a very common thing you want to do is manipulate KRM. But there are also interesting things like render Helm chart, changing annotations. The point is that all these functions are designed to be semantic changes, right? So for example, set namespace and the documentation here, I basically just give it a namespace and it changes everything to namespace, but it does it pretty cleverly. It knows which things to change, which things doesn't. It's clever, it's smart. It's not this dumb, if you will excuse me, I will compare with Helm. It's not a dumb text templating engine. Helm just generates text, but the idea of kept functions is that they have semantic knowledge of what these KRM resources are and can do something intelligent with them. And it's up to you. You can write your own kept function that does anything. So in this case, all I'm doing is, so I pulled that blueprint and I'm running eval is to run a kept function, and I'm giving it the image. And here I'm giving it one of its inputs, which is the namespace. So all it's going to do is on that kept function, all the resources in there, and I only have one, right, that deployment, it's going to give it that namespace. So this is what's kind of making it wet. This is a very, very trivial hydration, but I took something that's a blueprint that's missing information, and giving it what it needs, the information it needs in order to be deployable. And we can run a whole pipeline of kept images kept functions here, including we can do other, it doesn't have to be a kept function. We can have controllers that work within the space and also do the changes. And that's part of the stuff we're going to do, we're doing in FIA, right?
We could also do manual edits, right? It doesn't have to be.
Exactly.
File. Yeah.
Yeah, you can work with Git directly. You can work with package revision resources, right? You can change that. So, yeah, here though, I am noting.
So, Tal,
yeah,
I have a question whenever you're done with the thought. Yeah.
No, good. You can interrupt me. I'm good.
So I was under the impression, I obviously, most likely I'm wrong here. My understanding was you could directly, using the Porch command or package, you could directly clone from upstream repository to a downstream repository.
Yeah,
and then it will automatically run the KPD functions when you propose it.
Yeah. So thank you for that. Yeah, I was going to talk about it a bit later, but I can talk about it now. So this is the imperative way of using kept, so you can run individual functions. But there's also a declarative way of using kept functions where in that kept file, you can actually give it a pipeline for validation, for mutation. And then when you clone, you're absolutely right, you can render them that way. But the reason I did this locally here, because I did want to show, so let's say you want to have a kept function that does something for a very specific free5gc UPF, does some change that's very specific to that. It's not a general change. And you package that as a kept function, but maybe it needs to interact with other systems and other places. So the thing is, the place where Porch runs these kept functions, these declarative kept functions, is its own kind of kept function runner environment. Right, so that environment is very specific to that. So, but yeah, you do have a way to do it declaratively, but I think in Nefio so far, I don't think we actually have done that. We could, and we can mix and match. We can do things like basic validation in the kept pipeline, but if we have some sort of controller running from a vendor that wants to do the changes, then it's not running in that kept pipeline runner environment. It's going to be running on the management cluster in its own place. So I try to show here that, yeah, but anything works, to John's point as well, you can work directly with Git as well.
Well, we do both, actually. We do use the declarative pipeline for some things, like once.
Yeah, for some things.
But this is kind of showing what a human would do, where we would insert potentially a controller, like Tal is saying, like, if we weren't setting the namespace, but we're going out and we went to a spreadsheet and we picked an IP off the spreadsheet and we filled it in and then we copied it into the right place, like that's the equivalent of our IPAM, right? And that's done external to the pipeline because it's not hermetic. It's not like in its own little closed world. It's having to reach out to the outside world. But both, we'll do both.
Right. And yeah, this is via user commands at the command line, but there are Porch API equivalents to this. So if you create a controller, it can call the Porch API directly to do this pull and mutation and push as well, right? So you don't have to actually interact with Git, right?
I guess this is a bit like your find exec, if you like, in the Linux equivalent.
To bind exec. Sorry,
find, the find command, you can.
Oh, right. Yeah, exactly. The find command exec. Yeah. Right. So
it's more of a piping, I think, the way I look at it. It's a piping thing. So and the pipeline is a set of pipes together, and each of the pipes does something, and so that's how we have to look.
It's more like set and awk, like each function, right? You could run set, you could run awk.
Right. You know what? I will give you a quick look of just how it looks. I think it's under here.
Yeah, I read.
Function example. No, it is called a pipeline. Yeah.
Okay, so you can run a series of these. Yeah, brilliant. Okay.
Yeah. Right. So you can put a list of these, and also you can actually give the inputs to each kept command as a separate config map. So those inputs can come from elsewhere as well, right? So for example, if you have the namespace change, the blueprint might have the mutator already declaratively for changing the namespace, but it doesn't have the input yet. So you can add that input by injecting a config map, which actually has the name of the namespace, right? So
yeah, exactly. We offer a few ways to get those inputs. The sort of simplest, crudest way is for namespace is like we use the package name, the directory name. So if you rename it, but that's only one way, and then there's other ways we would have to do through injection. So we'll see some of that later in like the package management subproject, figuring out good ways to do that.
Right. So the important thing here in closing the loop, and I'm going to go over, I hope that's okay with people. The 2 hours ended up not being enough. Those who have to leave, I understand, but we'll keep the recording going because there's another important concept in Porch that we just didn't get to quite yet. I want to run this. I'm just going to run this whole thing. So the command is environment Porch demo deploy blueprint. Right. So again, it's pulling the blueprint, running the kept function. And by the way, that single kept command is why I had to use Docker instead of Podman. Kept, to get the image for that function, it uses Docker, and it just wouldn't accept Podman for me. But that's something that might be able to be fixed. And yeah, it created that.
That was a rock. That was a rock. When I was trying to get this working on my MacBook, these kept function images didn't have M1 version, so that finished me in the MacBook.
All right, please open a bug on kept and they'll fix it. Right, John?
And it's not broken. It's just not there. That's all.
The other thing is, right, if you want to run this stuff in a CI pipeline, you can't run Docker a lot of the time. People don't do Docker in Docker.
Right.
We have a WASM runtime, but it's kind of alpha and has some issues. So.
Right. So here I created this Edge package. I proposed it and approved it, and I just we can look at all the packages again. Oh, sorry, Porch. Oh, sorry, we switched to the Edge cluster too. So the final part, final part here of the script, it switches to the Edge 1 cluster and applies the root sync. So this is exactly the same as the previous demo. This is for config sync. Right, so I pushed the package using Porch, but now on the Edge cluster, I switched to the Edge cluster and started syncing. So we can actually probably see it here on the Edge cluster. Yeah, it already created, here's network function A and network function B, the two namespaces. And under network function B, I think it already shows, yeah. Don't you love it when demos work? So yeah, everything worked, config sync worked. So, but let me explain how that actually works. So I'm gonna switch back to so it's under platforms kind, use management. Let's switch back to the management cluster and again do our package get, because I want to show the deployment package. So here's the deployment package called Edge 1. So again, the name is the name of the repo, and then it gets a GUID. Here's the package name network function A. And you'll see it really looks the same as everything else. It's just published. Right. So again, from Porch's perspective, the fact that some of these are blueprints and some of these are deployments, Porch doesn't know about it at this level. Right? This is just another repo. However, it is a repo marked as deployment equals true. So it's a little bit special in that respect. But in terms of the actual package revisions, they're all the same. We're all just dealing with package revisions. That's it. But yeah, I can go now to, so I was in the blueprints repository, and I can go back to the Edge 1 repository. And it's exactly the same as the config sync demo we had before. Nothing's different. But there is a tiny little thing different here that I want to emphasize. So in the previous demo with config sync, I just put the contents of this directly. In this case, I used Porch to create this content. So Porch actually created this as a package, right? It has a kept file, right? This is, it's exactly a copy of the blueprint, except that now we have the namespace, right? The namespace was set to us by that kept function call that I called imperatively, right? So I mutated it and then pushed it here. But I will note here, all of this stuff is for Porch. Config sync doesn't know about config sync doesn't know what to do with kept files. right? So config sync, you can't run, at least right now, config sync is unaware of these cat files and won't be able to run any pipelines here. So if you have any declarative pipelines that you want to run, they will happen on the management cluster, not here quite yet, right? This is something, a feature that's not there, but it could be interesting to imagine a feature where you actually run the pipeline or parts of it at the edge cluster, at the workload cluster.
Ironically, so there's a kept community member who added an Argo CD plugin that would run a kept pipeline. So
Yeah.
ironically, probably Argo CD could actually run the kept pipeline config sync.
Yeah, it could be various components, right? Porch is really designed for the man. There could be another, as I said, config sync can have other layers and things that work with it as well, right? It's kind of, it does one thing, right? So it's unaware that this is a package, but we had to make sure that we deployed it here, that this is actually a deployable package, which is why we went through the approval process, right? So we made sure that everything in the end was actually something that's published. But it's very important to understand that the differences are semantic to us. The difference between a blueprint or a deployment package is one is dry and one is wet, but it's kind of up to us to understand that this is the wet one, right? That it has the namespace. So, I mean, Porch doesn't help us with that, right? We can add validators, right? We can add validators to make sure that it's actually deployable, but yeah. Config sync is rather dumb. All it sees KRM and just deploys it. So I won't go over this part of the edge cluster because it's exactly identical to what we had before, except that we do have another namespace here, but that directory is empty. We don't have a network function B directory yet. So there's nothing for it to sync, and it just won't sync anything. This is why now I'm going to go into the final part of the workshop. So if you go through the README, we went through the deploy blueprint. And yeah, we can go to the edge cluster and see it actually running there. You know, I think we already saw that with the dashboard. Porch has a new feature that was released last week. Well, new to us. It's been in development for a bit, which is called variants. I want to go over this aspect too, because it's very important to Nephew R1. So I'm going to switch. So actually, let's look at the script too. We're actually going to deploy a new CR. Yeah, let's look at what the CR is first. So it'll apply this package variant set. We're going to apply this file to the management cluster, right? So this is another Porch CR. So again, we saw two Porch CR so far. We saw a repository CR, and then we saw a package revision CR. And we also have package revision resources, which is not a CR, but you know, an interface. Here we have another CR called package variant set. And this does something interesting. It's actually one step before package revision, creating package revisions, right? When we created our deployment, we basically did our package init to create a new deployment a package, and it started off empty, right? And then we pushed data into it. So Porch can actually, you know, to go back to what Bala's point said before, Porch can automatically do that for us. And it does that through something called these package variants. A package variant set, and I'll explain in a minute what the difference between a set and just a package variant is, but we give it an upstream. So this is our blueprint. A package variant set has just one upstream. It's a one-to-many kind of thing. So I'm telling it, I want you to use this blueprint, this revision, and this repo. Very, very simple. But then I have targets, and targets is where I can give it a list of, and there are two ways to do the list. I can do it explicitly like I do it here. So I can say, I want you to deploy it to this repo with this name, and I can just list here all the different edge repos that I want to deploy it to. If I have 10 repos, I can deploy it, just write 10 of them down here. And what it will do, and I'll show you how it does it, it will actually automatically create a draft package there for us. So it will do that cloning and copying at scale, right? So I can give it many, many different repos, and it will do that for us. You can also use, instead of explicitly putting the name of repos here, you can use kind of selectors. There are two ways you can actually do that. So you can use, for example, a label. Let's say all your edge repos have a label called edge. Let's say you have far edge repos and near edge repos, and they have different labels. And you have 1,000 edge repos. So you can just give it a one-liner here saying to select on that label, and it'll just do that for that label. So package variant set is just a way to create a lot of package variants. The actual, and what the controller does, it actually creates one package variant for each target. So let's see that in action. Sorry, this was a bit of a roundabout way, but I think as usual, if you just see it in action, you can kind of see how it makes sense. So we're going to run this script that the first thing this script does is deploy that variant set that we just saw. And again, comment to myself, I need to break this down in a way that people can use. But okay, it's going to create that variant set. And what that variant set is going to do is going to create one variant, right? And I think in the README it's clear. So the package variant set controller will create a single package variant because we have only one target. If we had 100 targets, it will create 100 of those. And the package variant, we're going to see it in a minute, has a single upstream and a single downstream. It's a very, very simple kind of concept, right? And this is basically the kind of fan out, right? Because the topology, right, is a one-to-many connection between the blueprint and the places where the blueprint is going to deploy to, right? So you can, if you want, you can use package variant set if you want to do this kind of selection, or you can just create the package variants directly, right? One for each deployment that you want to create. So what is going to happen is in the script. So this is a little bit mysterious in the script because I'm going from applying that variant set to immediately looking for package revisions. And the reason is this, that the package variant set will, as I said, create a package variant for each target. The package variant creates a package revision in draft mode for that target, right? So every package variant is associated with exactly one package revision. And since I know that will be created, I'm just waiting until it will be created. So I am hoping that a future version, I did discuss this with John, that the controller will actually be able to update its status. So you'll be able to wait on the status of the package variant and package variant set and find out that they actually finished creating, you know, the package revision, which will also do a Git repo commit with that branch, the draft branch and everything. So there's a lot happening behind the scenes, but, you know, all I'm doing is waiting here.
I think you filed an issue for that in Natasha's.
Yeah. Excellent. Yeah. So, you know, this is a quite new feature. As I said, it was only really released first time to the public last week. Work in progress. But yeah, and it's actually really simple. I mean, at the end of the day, we're working with package revisions. Those are the real meat. This is just adds a little level of automation where it can automatically create these package revisions for us at scale, you know, based on blueprint. So it's kind of like our topology, right? So we basically, the early versions of Nephio, we had, right, this NF topology that we basically said per blueprint where it's going to go, like that fan out. What we're missing here too is the configuration of those. So, you know, how we actually hydrate. Again, I'm not talking about Nephio here, I'm just talking about Porch, but you can already imagine where Nephio would plug into this, right? So yeah, I'm waiting for this package revision to come. And once it's coming in, I'm actually doing exactly the same thing I did before, but the difference here, instead of pulling from the blueprint, I'm pulling from the deployment, right? Before I did it kind of manually. I took the blueprint, pulled it, mutated it, and pushed it as a new deployment package. But here I'm not doing our package in it because the variant already did that for me. All I'm doing is I'm pulling the deployment, mutating it, pushing it back, right? Because the copying is already happening with that package revision. So the workflow here is a little bit simpler. You know, I don't have to worry about talking to these blueprints directly. I can just reference them through the package variant and just work with the deployment packages directly. right? So this seems a bit more complicated, right, than the previous version, just deploy variant, just deploy the package. But I hope what you can see are that this is a useful tool using package variants to kind of manage this at scale easier. And you can also understand, that from Nefio's perspective, if it leaves package variant and the topology management to the package variant controller, the only thing Nefio would need to do, or any kind of mutator, is look at all the packages that are in draft mode, and they're going to be created automatically by this phase up here. It sees them in draft mode and runs the mutators then according to some conditions or other things that are in the package that need to be done. When all those conditions are satisfied, then it can approve, propose, and approve. Right? So this phase here, it all works on one package, a deployment package. Right? We don't have to do the cloning part manually ourselves. Porch can handle that for us. So it just simplifies things a little bit, right? And going to the code, you can actually go to the code of the package variant controller and look at it. It's one file. It's a very straightforward thing. It just looks for those variants, looks at the upstream, downstream, copies one from the other. Voila. It's pretty straightforward. And yeah, let's run this whole script, because I know we're way beyond time already. So I just want to make sure that we see everything running. So the script is environments Porch demo deploy blueprint variant. So here it waited for that package revision to be created, and then it just mutated that deployment package. And also at this point, we can actually look at the variant that was created. So
Tal, just to understand, at this point of time, when you say the deployment, are you working with, let's say we have cloned it to 10 particular edge clusters, let's say. In the steps that you're doing is for one particular edge cluster, right?
Yeah, in this case, I did it one because I didn't want to create 100 kind clusters. But yeah, you could potentially, list a lot of different targets here for different repos, or you can use a selector to just select a whole bunch of repos at the same time, deployment repos.
Right. And the step that you're doing right now, where you're pulling is from that edge cluster, right?
Yeah, and the thing is, I'm modifying one package here. So I'm not dealing with two packages. I'm just dealing with one package, which is the deployment package. So I'm not talking to the blueprint package at all. The blueprint package was defined in that variant set as the upstream. So it's more declarative, a bit more declarative.
But I think his question is, if you had 20 targets there, this code would have to be different because it would have to handle multiple. Right now, it's just waiting for the one. Maybe it's not this code.
Oh, yeah. Right. So yeah, assuming that you had 100 of these, then this would have to be repeated. But this is just doing it by a command line. An actual controller, right, would be reconciling these automatically. Right.
And this is exactly what the controllers, like the package specialization teams working on the injectors, they do this, right?
Exactly. This is specialization.
Got it. Okay, that's right. Okay.
This is it, right?
Thanks. Yeah.
This is the domain of specialization, mutating these deployment package. Yeah, that's basically it. So the inputs to Nefio could just be these package variants, right? That's the topology. If you have a higher level service orchestrator that has its own inventory and catalog and all these things, and people who design the topology and everything, all they need to do is spit out a bunch of package variant set CRs that tell us, they already selected which version of the network function they want to send where. They know which deployment it's going to because they have their inventory, and they just spit it out as a declarative way, and Nefio will take over and do all the rest, right? So first it will create the package revisions, that Porch does it, and then mutation kicks in. And then finally, when it's published, config sync actually deploys.
Yeah, thanks.
Right, but this is kind of Nefio's meat, right? In the shift left perspective, right? We're not talking here at all about what happens on the workload cluster after deployment, right?
Got it. Yeah, thanks.
Okay, so I did want to show you how so we'll switch back to the management cluster. And I wanted to show you that we can actually look at those package variant set CRs. So it's under, I think, network function. Oh, no, we called it Porch demo. Yeah. So yeah, this is the CR we created before. Here, let me, oops. Right, so this is the spec we created before. So it does have a status, right? But it's doesn't tell us that everything was created yet. But yeah, here's our single upstream and our single target. And let's look at the package variants that it created. Oh yeah, we just got all of them. Yeah, so it had a single package variant. And you can see this is the package variant set that created it, the name and name. So it's the owner. And here it is, it has a single upstream and a single downstream. But yeah, so this was a trivial set that had only one downstream. But if we had 100 downstreams, then we would have 100 of these. And each one of these in turn creates a package variant. Sorry, a package revision. So every package variant will be tied to a twin package revision. And once we get to the package revision, it's the same as we just did before, working with package revisions. Let's see that everything worked. I believe it did. So this was network function B. And network function B, it worked. Here it is. And here in the repo, if I refresh, here's network function B. So very similar approach to what we did with network function A, but in this case, we introduced the package variant as kind of an intermediary, right? Okay.
So just as a sort of aside, I don't know if I'm detracting, Taylor, I know we're over time, but so the other thing to think about is like in your package variant set, your upstream was a specific revision. Now, if you create a new upstream, a new revision of that upstream, and you change the package variant set, this whole declarative infrastructure will propose new drafts. So suppose that you had published all of those other ones. So it'll propose new drafts. So you actually, it's not a one-to-one package variant to package revision. You'll have a package variant, you'll have the published version,
Oh, yeah.
and then you'll have a draft for the new one, and once that's approved. So but that's how this assists us in the day two process.
Well, it could assist us. There are other ways to approach day two, right? Not to change your blueprints, right? This is about maybe changing the upstream.
Yeah, like if your vendor upstream, the vendor says, hey, I've got a patch release of my image, right? They're going to update their blueprint. And then you can propagate that all the way down, but you can take those changes on your own time frame. You don't have to take them immediately.
It's possible. I think in the telco world that works not a little bit differently, but yeah, anyway, that is a possibility. Yeah, technically that could work. So guys, this is it. This is everything that I wanted to convey. And I will say, there are parts of Porch that I didn't touch on, actually. There are a few other CRs. I really wanted to focus on the primitives that we're using. And just to get you guys comfortable with the terminology and the pieces and actually how they kind of interact with each other. So I know nobody's going to remember all of this, and the video is going to be there. And also the README, if you want to repeat this yourself, the README I try to make as clear as possible. So if you go through the Porch demo README, it really takes you step by step and tells you what happens and gives you some commands to kind of see what happens as you work. So this could be kind of a basis if you want to experiment with certain things, right? And in the future, I do have an idea of actually having a Nefio demo, but where that might be post R1, where we actually have a coherent and complete story, complete narrative. But yeah, thank you for your patience as usual. I'm going to stick around for some questions and answers, but I know we're already 20 minutes almost over time. And it's been a long 2 hours already. So any quick questions, or has everybody fell asleep already?
So thank you, Tal, for doing this, and thanks, John, for answering questions. So I have one fundamental questions. So we said that in the config sync case, we could essentially have multiple branches pointing to different edge clusters. If somebody were to use it, obviously when we publish something, when we propose something, it has to merge not with the main, but with that particular branch for that intended for that cluster. How does that work? The proposed workflow, if at all we,
That's a pretty good question, because as far as I understand, config sync is more flexible than Porch here, right? Config sync has, directories, branches, etc., that you can do, but Porch pretty much puts every package in the root directory. I don't know if that's just by default or it's configurable, but Porch does have a structure to the repo. So if you want to use config sync and Porch together, you kind of have to go by the way Porch organizes things. But John probably can say more.
Porch is opinionated for sure. And it's much newer than config sync. Config sync has been around for quite some time and is a GA product we've got many customers using. Porch is new. And so it's a lot less flexible. In theory, you can create a repository which has a directory, and then the packages go into that, but it is flat under a repository. Now there's issues with the repository. I opened a bug just the other day on the repositories that aren't at the root. But in theory, you can create a repository. The repository resource itself points to a branch and a directory, and then you're flat under that. But config sync, yes, it probably offers more features. So config sync lets you create different syncs, either root syncs or repo syncs, which are scoped to a namespace that are pinned to a commit or a branch or a tag. And so we're not using any of that in R1 because we're trying to simplify. So we made this fundamental basic assumption that one repo, one workload cluster, config sync is just dumb and just slurps everything in. That's something we'll likely break at some point, but not in R1. So at some point we might say we have 10,000 RAN clusters and they're all literally identical. We don't need to do any mutation on the management cluster side. Maybe they do some mutation down in the workload cluster. So we don't want to create separate repos for each of those. We just want them all to sync to that. Then we would we would break that one-to-one association. But just for simplicity in R1, we're not doing that.
Right. I'll add, the Nepio code base for R1 is very focused on Porch for mutations, right? Because the ability to do those mutations is kind of designed around the kept package in draft, right? But config sync is much less required by Nepio, right? In a way, Nepio doesn't really care how the resources get to the edge repository. We're not heavy users of config sync in that respect, at least for R1, right? And it's a rather dumb tool, right? So if somebody wants to do some other way to get the resources to some other tooling, I mean, that won't break Nepio, right? If somebody wants to use a different tooling to get things to the edge cluster.
Yeah, so in this particular, just for my understanding, thanks Tal and John for answering this. So essentially we are using the main branch of each cluster, and that's what when we propose, that's where the changes get merged, and all the kept pipelines would be run when it gets into the main, and that at that point of time, that's going to be that's what is get synced by the config sync on the edge clusters.
Yes, main branch, the root and the main branch. So basically you just suck the whole thing in and apply it. And yeah.
Okay, yeah, thank you. Yeah.
All right, guys, I'm tired too. So
okay. Thanks very much, Tal. Really good.
All right, I'm going to stop the recording then, and thank you all. Tal, this is awesome. I unfortunately missed about an hour of it, but it seems like it was totally awesome. So I'll watch the rest later.
Yeah.
Hey, thanks, Tal. I appreciate it.
Thanks, everyone.
Cheers.